Hi Year 6, Mr. A here again for another maths lesson, and following on from the work that we've been doing where we've been finding common denominators, I thought it'd be good now to move into adding fractions as well, where we're using the same sort of techniques. Okay, so that's what we're going to be doing this lesson. As you know, I like to get our brains into gear before we do anything else, so I thought finding amounts of fractions would be a good idea to get us started today, just to jog your memories. So pause the video and have a go at these for me. Okay, let's have a look, see how we've done with the answers. See if Mr. A can manage to write neatly on his screen, or attempt to write neatly. So first of all, let's get a pen, and what we want to have a look at first is 1/6 of 72. So if you remember, kids, it's basically that line in between the numerator and the denominator is a dividing line. So what we're trying to do is we're writing 72 divided by 6. That's what we're doing, right? 1/6. We're sharing 72 into 6 equal parts. So how many 6s? 72. That's right. It's 12. Helps if you know your times table, guys. Right. 3/5 of 45. Well, first of all, we have to find out, if you remember, what 1/5 is. So if I can write semi-neatly, 1/5 was how many 5s go into 45? Well, that's 9. And then can you remember what you do? You divide by the bottom and times by the top. That's it. So what we do now is we take that 9, because we found 1/5, and we multiply it by 3, because we want 3 of them. 3 9s are 27. So our answer there is going to be 27. Okay, good. Hopefully you remembered that. So on this one, we want to find out what 1/7 of 700 is. What's 700 divided by 7? Yeah, it's 100. 100 lots of 7 is 700. So we've found out what one lot is. We want 4 of them. So it's 100 times by 4. It's going to give us 400. Okay. Now, these ones are the slightly trickier ones, especially as they're down the bottom of the screen. I've got to try and write on them. If 1/4 of 6 is the whole amount, sorry, if 1/4 is 6, what is the whole amount? So we're dealing with quarters. So remember when we were doing them, I was using some bar diagrams to help us out. Let's just try and divide this into 4 equal parts. There we go. There's my quarters. And one of them is worth 6. Right? That means every one of them is worth 6. So if 1/4 is 6, what's the whole amount? Well, we've got 4 lots of 6. So our answer is going to be 24. Super. Right, now you know that one. That's the easy one. We need to use that to work out the next one. So this time we're dealing with sevenths. This should be good. Try and get 7 equal parts. 1, 2, 3, 4, 5. It's not going to happen. 6, 7. That's roughly 7 equal parts. I'm just looking at my drawing. Right. Now it says 3/7 is worth 21. So from there to there is worth 21, 3 of them. So what we need to do is work out what 1 is worth. Well, that's easy, because we can divide that 21 by 3, yeah, to find out what each one is equally. So if we divide 21 by 3, what have we got? Well, how many lots of 3 make 21? 7. So each one of these is worth 7, but that also applies to these, doesn't it? And because we're dealing with sevenths, right, we've got 7, and there's 7 of them, so we end up with 7 7s, so that gives us an answer of 49. Right, how did you do? Hopefully you remembered what we did a few weeks ago when we started looking at fractions. If you got them all right, excellent work. Okay, let's keep it simple. We're moving on to adding fractions. We're going to start right at the very bottom and work our way up. Okay, so don't worry, we'll take things nice and slow Maybe you've done adding fractions before and you understand it, but because some of us don't know or some of us need a reminder, you're just going to have to bear with us as we go through. Okay, let's make a start. Okay, though, what have we got here? We have got 3/8 plus 2/8. Now, the fractions have the same denominator. Okay, we're all right with these. There we go. We're working with eighths. 3/8 and 2/8. Now that equals 5/8. Does that make sense to you? Well, let's have a look at it. Yeah, 3/8 and 2/8 does equal 5/8. Because what happens is you add the top like you would normally, so you add the numerators up. The only thing is, what you don't do when you're adding a fraction is you don't add the denominators. Okay, they need to stay the same, right? Because that's the fraction that you're working with, eighths. Right, bear that in mind. So have a look at this one. 4/7 and 2/7 equals 6/14. Going on what I've just told you on the last slide, is this correct? No, it's not. Right? Who can explain why it's wrong? Think about what I've just told you on the other slide. It's wrong because sevenths are being added. Okay, and what did I say to you? Don't add the denominators. All right, so the answer must be in the sevenths. All right, so the 6 is correct. 4 and 2 is 6. But 7 and 7 is not 14. We've got to keep the denominator the same, so it must be sevenths. Okay, there we go. So 4/7 and 2/7 is 6/7. Right, here are a few for you to have a go at now for me. Okay, and then we'll have a look at the answers in a moment. So have a try at these. Pause the video now. Okay, not too difficult for us, I hope. The first one, 4/7 plus 1/7. Don't forget, we're only adding the numerator. Okay, the denominator stays the same because we are dealing with sevenths. So you should have an answer of 5/7. Next up, 4/8 plus 3/8. The eighths stay the same, don't they? So all we've got to do is add 4 and 3. Really hard maths this is, kids. 7/8. 3/6 plus 2/6. Sixths stay the same, remember? So we should have 5/6 and then 2/9 and 5/9. That's right, you've got it. The ninths stay the same, so our answer should be 7/9. Okay, I'm not even going to say well done if you got those right, because you should have been right on the ball with those, no problem at all. Okay, this time, right, let's read this one aloud. This one's going to be 1 and 1/5 plus 3/5. Is there anything different? Is there anything going to change here for us compared to what we've just done? Well, these fractions can be added because they still have the same denominator. Yeah? We're dealing with fifths, aren't we? So if we're dealing with fifths, think about it like this. 1 whole, yeah, that's still the same. Add 1/5, add 3/5. That's going to equal, any guesses? Nice and easy. 1 and 4/5, because we're not adding any whole numbers, are we? Right, that's still the same. There we go. 1 and 4/5. Right, so that's quite simple to understand, isn't it? We know how to add numbers that have got the same denominator. Right? All we're doing is adding one whole number. Okay, could have been different if we'd got larger numerators to deal with, but for this, keeping it simple at the moment, let's just stick with adding that one whole onto it. Okay, here we go again, some more for you to have a look at. This time we're involving mixed numbers, so remember what we said, the principle stays the same. Let's see if you can work these ones out. It should only take you a couple of minutes. Press pause on the video now, guys. Okie doke, let's see how you've done. Should be easy peasy lemon squeezy. First one, 1 and 4/7 plus 1/7. Don't forget the denominator stays the same. We're not adding any other whole numbers, so we end up with 1 and 5/7. Next one across, 1 and 4/8 plus 3/8. No difference to us. The denominator stays the same. 4 and 3 is 7, something you would learn to add up as a little one. Plus your whole number, 1 and 7/8. Next one, 2 and 3 6 plus 2 6. We've got 2 and 5 6. And the last one I threw in there just to test you out. We've got 2 whole numbers to add there, haven't we? So 1 and 1 is 2, but then our denominators are the same, so it's 2 and something ninths, but it's going to be 2 and 7 ninths, isn't it? There we go. Hopefully that one didn't catch you out and you got them all correct. Okay, let's move on to the next step then. Okay, what about these fractions then? Can we add these together? The denominators are the same. Yeah, they're both 8s, so we should be all right, shouldn't we? So what will we have? How many 8s are all together? Well, we're definitely sticking with 8s. But on the top, what have we got? 7 and 3, number bond 2, 10. So we've got 10 8s. This is the right answer, but it's been written as an improper fraction. We've done these, guys, so we know what we're doing. Right? How many 8s are there all together? 10 8s. So, what is 10 8s as a mixed number? We change the improper fraction into a mixed number and it becomes 1 and 2 8s, doesn't it? Okay, how many 8s go into 8 8? 8 of them, obviously. And what's left over? 2. We've done this work, so it's a natural progression of what we've been learning. All right, and there we go. We can then simplify it, can't we? Right, we can take this a step further, because what's a common factor of 2 and of 8? Well, 2 is, yeah, 2 goes into 2 once, 2 goes into 8 4 times, so it's 1 and 1/4. Always try and simplify it if you can. Good practice just to try and remember. So if you've got any questions or comments about this, email me. If you're working in school, one of the key work kids, ask one of the teachers that are with you. Okay, brilliant. Okay, hopefully this is easy for you to understand. Basically, how many 8s do we have? Right, we've got 10 8s. There they are as a bar diagram. Okay, there's our 8 8ths, and then we've got 2 more, giving us our 10 8ths. Hopefully that's okay. Or we see them as one whole 8 8ths, one whole, and 2 8ths. Yeah, so that is where we're going from there and there. Okay, brilliant. Well, what about this end bit here? This is something that we're having to go over again. It's something that we've done before. It's about that 2 8ths becoming 1/4. There we go. We've done it before where we've done 2 bar diagrams together, the same size, to show that the fractions are equal. Okay, you're getting the idea now, so I want you to pause the video and have a go at these practice questions as well. Okay, let's get some answers coming up. Let's see which is the best colour for us to write in. We've got 4 7ths and 5 7ths, so that gives us 9 7ths. 7 goes into 9 once. Let's put an equal sign. 7 goes into 9 once, and then we've got how many left over? 2 7ths left over. Let's see if we've got that right. Let's get rid of that first. 1 and 2 7ths. Brilliant. Right, our next one. 4 6 and 3 6. That's going to give us 7 6. How many times does 6 go into 7? Once, and we've got 1 6th left over. Let's see if we're right there. Boom, brilliant, fantastic. And let's go for Next one, we've got 3/4 plus 2/4. Oops, Mr. A's managed to make the line disappear there. Sure, it'll come back in a minute when we look at the answer. So 3/4 and 2/4, we're dealing with quarters. 3 and 2 is 5. So how many 4s go into 5? 1. How many is left over? 1/4. Let's see if Mr. A is correct. Get rid of my pen. Get in there. Oh, and there we go. Our line's returned. Now this last one, oof, we've got our whole number. Now, probably the best way to do this is to turn that mixed number into an improper fraction so that we're still dealing with the same denominators. So let's get the pen again. Onto red. So we're dealing with ninths, aren't we? Yeah. So what is 1 and 4/9 as an improper fraction in ninths? Well, 1/9 is 9 plus 4 is 13, isn't it? Agreed? And then we've still got 7/9. What does that give us? 13 and 7 is 20. Don't forget the denominator stays the same. So we've got 20/9. Well, we need to turn that now back into, let me let the equal sign there. We need to turn that back into a mixed number. How many 9s go into 20? Well, 2 9s are 18, so that's 2. And what's left over? 18 up to 20 is 2, and we're dealing in ninths. So 2 and 2 9s. Let's see if we are right with that one. And again, we're experts. Fantastic. Right, if you're not sure about these, right, I've explained all through them. Stop the video, go back a couple of minutes and listen to the explanations again. Okay, you can listen to it time and time again until the penny drops. Okay, well done if you got those right. Right, now you're experts at adding fractions with the same denominators. I want you guys to have a go at these questions for me, please. And take care with the last couple of questions. All right, just might need a little bit more thought, but there is nothing there that you haven't learned that you could solve these problems, stopping you from solving problems. So pause the video now, keep your work nice and neat for me, please, and away you go. Okay, here we go then. Let's grab a pen and have a look at these answers. First up, we are dealing with fifths, aren't we? So let's put that in. And 7 and 4 is 11. We've got 11 fifths. 5 goes into 11 how many times? Well, twice, because 2 5s are 10, and that leaves us with 1/5 left over. Can we simplify it? No, we can't. So the first one is 2 and 1/5. Next up, we are dealing with sevenths. We've got 3 and 6 on the numerators, so that gives us 9. That gives us 7 into 9 goes once with 2 sevenths left over. Can we simplify that? Is there a common factor between 2 and 7? No, there isn't, so we can't simplify it. It's 1 and 2 sevenths. Next up, we've got 1 whole 1 and 4 ninths plus 2 ninths. Let's convert everything to ninths, shall we? So 1 9 is 9 plus 4, that's 13 ninths. And we're going to add that to 2 ninths, which gives us 15 ninths. Okay, now we can turn it into a mixed number. How many times does 9 go into 15? It goes in once, but then we've got to go from 9 up to 15. Well, that's 6, isn't it? 6 ninths. Now look at that, guys. Can we simplify it? There's a common factor between 6 and 9. What goes into both 6 and 9? That's right, 3. So we've still got our whole one. How many times does 3 go into 6? Twice. How many times does 3 go into 9? 3 times. So we've got 1 and 2/3. Are we alright? Can we simplify it any further? No, we can't. Okay, good stuff. Who got that one? Hopefully a few of you. Well done. So we do the same again here. We've got 1 and 3/5. So let's convert it all to fifths. There we go. Right, 1 5 is 5 plus 3 is 8. So now we've got an improper fraction. And we've still got 4/5 on this side. Fifths at the bottom. 8 and 4 is 12. now we've got an improper fraction. 12. We've done the addition, but now we've got to turn that back into a mixed number. 5 into 12. Well, 2 5s are 10, so it's 2 whole ones, and there's 2 fifths left over. Can we simplify it? No, we can't, so that's how far we're going to go. Now this time we've got eighths, 7 eighths, that stays the same, but this time we've got 2 whole ones plus 3 eighths. So 2 eighths are 16, let's put my eighths in first. 2 eighths are 16 plus 3 more is 19 eighths. So 7 and 19 is 26. 26 eighths. How many times does 8 go into 26? Well, 3 eighths are 24. That leaves me with 2 eighths left over. Can I simplify that, kids? I can, can't I? I've got 2 even numbers there, 2 eighths. So we've still got 3 as our whole number. That stays the same. What goes into 2 and 8? Well, it's 2. 2 goes into 2 once, and 2 goes into 8 4 times. So we've got 3 1/4, and that's as far as we can go. Alright, well done. Right, on to number 6, where we've now got 2 whole numbers that we're going to add together. Does this stop us? No, it doesn't, because we can still just turn everything into sevenths. I'm just getting near the bottom of my page now, so I'm finding it a bit difficult to write. So 177 plus 4 is 11, so 11 sevenths plus, now this time we've got to do 177, let's get the sevenths in there first. 177 plus 5 is 12. Right, we've got 2 improper fractions to add together, but because the denominators are the same, that stays the same. 11 and 12 is 23. Now we've got our addition done, we need to turn it back into a mixed number. 7s into 23, well, 3 7s are 21, so that's our whole number. 21 up to 23, that's a difference of 2, so it's 3 and 2 sevenths. Can we simplify that? No, we can't, so that stays at 3 and 2 sevenths. And finally, we've got 3 and 2/3 and 1 and 1/3. So again, we've got 2 whole numbers that we need to add here. Let's turn everything into thirds, shall we? There we go. Let's put that in to remind me. 3 3s are 9, plus 2 more is 11. And then on the other side, we've got 1 3 is 3, plus 1 more is 4. So now we can do the addition part, see how many thirds we've got. 11 and 4 is 15. So 15 thirds. We've now got to turn that back into a mixed number because we've done the addition. 3s into 15. Well, what have we got? 5 3s. So have we got any thirds left over? No, we haven't. 5 whole ones. That's our answer. Right. One of those occasions when you don't need to have a fraction in the answer. Brilliant. If you've done all those and you've got them all correct and you remember to simplify those that needed simplifying, really, really well done. Okay. Well done, everybody. A good lesson. It might have been, like I say, a recap for some people. It might be something new for others. Either way, we're going to take it from the lower steps and we're going to work our way up with it. So we've looked at denominators being the same, adding them. And in the next lesson, we're going to look at adding fractions that have different denominators. So I can leave you to think about how we might solve those kind of problems. And remember, if you didn't get it the first time, go back through the lesson and listen again. And I'll see you soon in the next lesson. Bye for now.